Hello everyone, I am Said Kurmayed. Welcome to my YouTube channel. In chapter 3 part 1, I already covered various types of pollution in a dataset. Now I want to delve into part 2, which is related to data manipulation. By data manipulation, we focus on elements in a string column and apply some function based on those elements. So let's go to part 2 and see those functions. Here you can see the topics that I want to cover in this part. First, I address mid, right, or left functions. Next, reforming values. Then I will explain character-based separation, and finally, wildcards. Again, I use our Python script to explain these topics. So let's go to our Python script and proceed with the first type of data manipulation, which is mid, right, and left functions. By using mid, right, and left functions, we can extract a part of a string in a column with a string format. So let's see some examples and see how these functions work. In the first example, I focus on retailer's data frame. As I explained previously, we have a data set in InputData. Here you can see different tabs in InputData, and I use this data set in entire training. So I already read the retailer data frame and I print it here. Now I want to apply mid, left, and right functions on this data frame. In this example, I want to focus on column retailer number. I'm in the first column in the data frame, and I want to extract the first 2 digits, the second 2 digits, and the last digit in retailer number. So as you see below, the retailer number is a string format and it contains 5 digits. Let's go to our slide where I can explain mid, left, and right functions. Let's consider the following string. Here I write down the elements of this string separately. So as you see, the element of these strings are 3, 4, 6, R, T, 2, 5, 0, Q, M, and N. In Python, we can use 2 ways of indexing for string columns. The first way of indexing is 0, 1, 2, 3, and so on. I mean, the first element of a string, which is 3, has index of 0. The second element of a string, which is 4, has index of 1. The third element of a string, which is 6, has index of 2, and so on. Another way of indexing is to assign index of -1 to the last element of a string and give index of -2 to the second element of the string from last, I mean M. So N here has index of -1, M has index of -2, Q has index of -3, 0 has index of -4, and so on. So there are 2 ways of indexing in a column with a string format. Now in examples below, I want to explain you how to extract specific elements in this string. For this purpose, we can use .str function. And inside of the bracket, we can specify the range of indexes in a string column. So in the first example, I use .str with range of 3 till 7. Please note that the last number in this range is not included in the range of indexes. So in this example, we extract the index of 3, 4, 5, and 6. It means 7 is not included in the range of indexes. So element with index of 3 is R, element with index of 4 is T, element with index of 5 is 2, and element with index of 6 is 5. So by using .str in bracket 3 till 7, we extract RT25. In the second example, I use .str 7 till 10, and it means I want to extract index of 7, 8, and 9. As you see, 10 is not included. Element with index of 7 is 0, element with index of 8 is Q, and element with index of 9 is M. So by using .str 7 till 10, I extract 0, Q, M in string above. In the third example, I want to use the second way of indexing. So I use .str -8 till -4, and it means I want to extract elements with index of -8, -7, -6, and -5. So as you see, -4 is not included. Element with index of -8 is R, element with index of -7 is T, element with index of -6 is 2, element with index of -5 is 4. So by applying this function, I extract RT25. So as you see in the first and third example, we extract the same elements, but with different way of indexing. In the first example, we use the positive way of indexing, and in the third example, we use the negative way of indexing. So let's go to example 4. Here we use .str -3 till -2, and means only index of -3, because -2 is not included. The element with index of -3 is Q, so the result of this function is Q. Let's see example 5. In this example, we use .str. We don't mention the first index till 4. Please note that when you don't mention the first element in the first way of indexing, it means from first element till 4, and it means index of 0, 1, 2, and 3. And as you see, elements with index of 0, 1, 2, 3 are 3, 4, 6 are. In example number 6 also we use .str, where the first index is not mentioned and the last index is 2. And it means I want to extract elements with index of 0 and 1, which is 34. Let's see example number 7. So as you see, the range of indexes is -5, and there is no ending for the range of indexes. And it means range of indexes is -5 till end of the string. That results in indexes -5, -4, -3, -2, and -4. So as you see, by applying this function, we extract the last 5 elements of the string, which is 50, Q, M, N. And in the last example, I used .str -1 till end of the string. Since the end of the string has index of -1, it means only index of -1, which is n. So by applying this function, we extract the last element of the string, which is n. So as you see in the last two examples, example number 7 and number 8, I extract the right part of the string. So that's why I call them right functions. And in example number 5 and number 6, I extract the left part of the string. That's why I call them left functions. And in the first 4 examples, I extract some elements in the middle of the string. So that's why I call them mid functions. Now let's back to our Python script and see how can I apply this function on retailer data frame. As I explained previously, I focus on retailer number in this data frame. Based on my knowledge, the first 2 digits in retailer number shows the country code. So in the first line of the code, by using this function, I extract the first 2 elements in retailer number, and then I store it in a new column and I call it country code. As you see in the resulting data frame, a new column with name of country code is added, and it shows the first 2 elements in retailer number. For example, in the first record, we have 00 as the first 2 elements, and country code is 00. In the second row, also, the first 2 elements are 00, so the country code is 00. In record with index of 5, we have 10 as the first 2 elements, so the country code is 10. And in the second line of the code, I use this function to extract elements with index of 2 and 3, which are the third and fourth elements in retailer number. And I store them in a new column that I call it retailer size. So again, in the resulting data frame, a new column with name of retailer size is added that shows the third and fourth elements in retailer number. For example, in the first record, the third and fourth elements are 81, so the retailer size is 81. In record with index of 4, the third and fourth elements are 82, so the retailer size is 82. And in record with index of 5, the third and fourth elements are 11, so the retailer size is 11. And in third line of the code, I use this function to extract the last number in retailer number. And I store it in a new column and I call it retailer type. In the resulting data frame, again, a new column is added with name of retailer type, and it shows the last element in retailer number. So as you see in the first record, the last element is 7, so retailer type is 7. In the second row, the last element is 9, so retailer type is 9. In third row, the last element is 0, and retailer type is 0, and so on. Let's go to the next example. In the next example, I want to focus on construction date. This column in data frame. In this column, the first 4 elements shows the year of construction. The second 2 elements shows the construction month, and the last 2 elements shows the construction date. So by using this information, I want to extract the construction year, construction month, construction date, and I report them in separate columns. So as you see in the first line of the code, I use this function to extract the first 4 elements in construction date, and I store in construction year column. In second line of the code, I use this function to extract the 5th and 6th element in construction date, and I store in construction month. And in third line of the code, I use this function to extract the last 2 elements in construction date, and I store it in construction date. Let's look at the resulting data frame. In this data frame, we have construction year, which is the first 4 elements in construction date. So as you see, 2070 is construction year, 2090 here is construction year, 2007 is construction year, 2004 is construction year, and so on. We have construction month, which is the extraction of 5th and 6th element in construction date. So construction month here is 04, this is 04, April. Here is 03, 03, March, 09, here 09, September, 10, 10, October, and so on. And we have construction date, which is last 2 element in construction date. So here we have 17, so 17, here we have 25, here's 25, here we have 19, and here we have 19, 28, and here 28, and so on. So as you see in this example, by using .str function, I extract construction year, construction month, and construction date out of construction date. Here I want to mention an important note which is related to data type in construction date. If you use .info function on this data frame, you will see the construction date is in integer form. And as explained previously, we can use .str function only for columns with a string type. Here I want to mention that you can use .str function on columns with integer format as well. But before applying the function, you should use as type str function to convert the data type from integer to a string, and then apply .str function. In this case, since construction date is in integer format. As you see in 3 lines of the code, I use as type str function to first convert construction date to a string and then apply .str function. So until now, I explained you meet right left function, and I provide you 2 examples. One on the Taylor number with the string format, and one on construction date with integer format. And I explain you how to extract some information out of those columns. Now let's go to the next topic, which is character-based separation. In this section, I want to explain how to split a string in a column with a string format based on a character in that string. Let's suppose that data frame df with column name contains a character. Now I want to split column name based on that character and take the left part of the string. So as you see, I use .str.split function for this purpose. And here in bracket, if I use 0, I take the left part of the string. And if I use 1, I take the right part of the string. Now let's go to our Python script to explain you what I mean with character-based separation. This time I want to focus on suppliers data frame, which represents information related to our suppliers, like supplier code, supplier name, the country of the supplier, city, and so on. In this data frame, I want to focus on reference column that has a specific format. As you see in reference column, we have at the first position the country of the supplier, in this case USA, as you see is USA, Italy, and then a slash and supplier code. So as you see, supplier code is here, and here we have supplier code, and then in parentheses we have supplier name. So here supplier name is Vitas, we have in parentheses Vitas. In this case we have Kale, and here we have Kale. So in this section, I want to suppose that we don't have supplier code, supplier name, and country, and I want to explain you how to extract this information by using only reference column. I mean, by using reference column, I want to extract the country, the supplier code, and supplier name. So in the following, let's see how I do it by using .split function. Here in cell 98, I want to extract country of the supplier out of reference column. As you see in reference column, we have first country, then 1 slash and supplier code. So as you see, I can use .split function in reference column and split the reference function by slash and take the left part of the slash. Please note that when I use 0 in bracket, it means I want to take the left part of the slash. Then I store the result of this function in a new column and I call it country1. So as you see in the resulting data frame, we have country1, which is the country of the supplier. Now, next example, let's see how can I get supplier code and supplier name out of reference column. So again, we use .split function and we split reference column by slash. And this time I take the right part of the string. So I use 1 in bracket. Again, by using 0, I take the left part of the string before a slash. And by using 1, I take the right part of the string after a slash. So this function means split the reference function by using a slash and take any part of the string after a slash. Then I store the result of the function on a new column, which is supplier code and name. So as you see in the resulting data frame, a new column, supplier code and name is added, which is the right part of the slash. So in this case, we take this part. In the second row, we take this part. In third row, we take this part, and so on. And then in the next step, as you see, we split supplier code and name by using open parenthesis, and I take the left part of the parenthesis. And I store the result of function to a new column, and I call it supplier code 1. So in the resulting data frame, we have supplier code 1, which is the left part of open parenthesis in supplier code and name. So as you see, the left part of open parenthesis here is supplier code. In this case, the left part of open parenthesis is supplier code, and so on. So as you see in supplier code 1, I extract the supplier code out of reference column. And let's see in the next step, how can I get the supplier name by using reference column. Again, I focus on supplier code and name, and I split that string by using open parenthesis, and I take the right part of the parenthesis, and I store the result of function to a new column, and I call it name0. So as you see in the new data frame, a new column name0 is added, which is the right part of supplier name column after open parenthesis. So the right part of open parenthesis here is this, the right part of open parenthesis here is this, the right part of open parenthesis here is this, and so on. And in the next step, I focus on name0 and I split that string by using close parenthesis, and I take the left part of the close parenthesis and I store the result of function to a new column and I call it name1. So as you see in name1, we take the left part of close parenthesis in name0. So the left part of close parenthesis here is this, the left part of close parenthesis here is this, and the left part of close parenthesis here is this. So as you see in 2 steps, I extract the supplier name out of reference column. So as you see, by using .split function, I extract some meaningful data out of a column, which is combination of some information. In the example that I already provide you, you see the reference columns contains information related to country code, supplier code, and supplier name. And as you see, these 3 information are combined with a specific format. Country code and supplier code are separated by slash, and the supplier name is in parentheses. Having this specific format, we can use .split function to extract meaningful data. That's why I call this function character-based separation. I want to mention one important note here. Sometimes you want to split a string by using a space. For example, in this case, I split name 0 by close parenthesis. Now suppose that name 0 contains a space and I want to split name 0 by that space. In this case, put one space between two quotations. Again, please note that space is a character in Python. So here there is one space and this space is character, like parentheses, like U7, and these are characters. And a space itself is also a character. If you open one quotation and close it immediately, like here, it means null value, nothing. But if you put one space, it means a character, and it is a space. You can put also two space. So in this case, we have one and two space. So it is possible to split a string by using a space. Now let's go to our slide and summarize the character-based separation. Let's suppose that in data frame df we have column name with a string format, and I want to split this column by using a special character. If I put 0 in bracket, I take the left part of character, and if I use 1, I take the right part of that character. That's all. Now let's go to the next topic, reforming values. Let's suppose that we have a string, which is this shows an example. Sometimes in column with a string format, we are interested to change the format of the string. For instance, in this case, by using .title, I convert the first letter of each word to a capital letter. In the second case, by using .lower, I convert all letters to a small letters. And in third case, by using .upper, I convert all letters to capital letters. Let's go to our Python script and see one example. In this example, I focus on retailers data frame. So as you see, manager column, we have the name of managers in a string format. In the first line of the code, I use .strip function to eliminate the extra spaces. In second line of the code, I use .title function that convert the first letters to capital letters in the resulting data frame. The first letter of manager name and manager family name are capital letters. In second line of the code, I use .lower function that converts all letters to small letters, and I store the result in manager 1. So as you see in manager 1, all letters are small letters. And I use .upper function to convert all letters to capital letters, and I store result to manager 2. As you see in column manager 2, all letters are capital letters. So as you see, by using these functions, we can reform columns with text format to a desired form. Now let's go to the next topic, which is related to wildcards. In this section, I want to explain how to filter on column with a string format based on element of the string. Let's go to our data set where I can explain what I mean exactly by wildcards. Let's go to retailers data frame and cancel column manager that shows the manager name. Now here, if you filter on AR, it shows all manager names that contains AR. So as you see here, we have AR, here we have AR, here we have AR, here we have AR, and here we have AR. So we filter on manager names that contain AR. Now, if I want to filter on manager names that start with AR, I need to just put one star here. By putting on a star, it means filter on manager names that start with AR. So as you see, no manager name starts with AR. Let me change it to A star. That A star means filter on manager names that start with A. So as you see here, we have two manager names that start with A. And if we use, for example, star A, it means filter on manager names that end with A. So as you see, these three manager names end with A. So let's see, for example, star T. So as you see, only one manager name ends with T. Now I want to explain how to do this exercise in Python. In slide 15, I explain how to filter on strings that start with a specific elements. In slide 16, I explain you how to filter on a string that ends with a specific element or elements. And in slide 17, I explain how to filter on strings that contain a specific element or elements. So let's see the syntaxing. Suppose that in data frame df column name has a string format, and I want to filter on records where strings start with character 1. Then I can use this syntax. And in the second case, I want to filter records in column name that starts with character 1 or character 2 or character 3. Then this is the syntaxing. So as you see here, I use .str.contains function. There is another function in Python that you can do the same exercise. Again, suppose that we have data frame df with column name with a string format. Now I want to filter on records that start with character 1. Then we can use this syntaxing. In this method, instead of using .contains, I use .starts with. And in the second case, I want to filter on records that start with character 1 or character 2 or character 3. Then it will be the syntax. We have similar syntaxing for ending. So in the first method, I want to filter on the strings that ends with character 1. Then I use this syntaxing. And in the second case, I want to filter on records that ends with character 1 or character 2 or character 3. then I use this syntaxing. So in the first method, I use .contains function, and in the second method, I use .ends with function. So again, in the first case, I want to filter on column name that ends with character 1, and in the second case, I want to filter on column name that ends with character 1 or character 2 or character 3. And lastly, if I want to filter on content of the string, I use .contains function. So in the first case, I want to filter on column name that contains character 1, then I use this syntaxing. In the second case, I want to filter on column name that contains character 1 or character 2 or character 3. Then I use this syntaxing. And in the second method, again, I use .contains, but with different syntaxing. So this syntaxing is equivalent with this syntaxing. Both syntaxing filter on column name that contains character 1 or character 2 or character 3. And lastly, I have one important note here, which is related to null values. As I explained here, before using this function, first you need to handle null values in the column that you want to filter in on. So as you see in most of the Python functions that work on string columns, you need to first handle null values. And almost in all cases, you need to fill null values with a specific string and then apply the corresponding functions. For instance, in the previous example, if I want to work on manager column, and if there is some null values in some records, I can first fill those null values with a specific string, let's say, for example, unknown, and then apply those functions. Now let's go to our Python script and see some examples. In the first example, I can insert items data frame that shows information related to items like item number, item name, the warehouse that item is located, sales code, stock on hand, and so on. Let's see the first example. In the first example, I want to filter on item names that start with F. Then I can use this syntaxing. So as you see here, we see records where item names start with F. In the second example, I want to filter on item names that start with B. Then I use this syntaxing. And as you see in all records, item names start with B. And in the third example, I want to filter on item name that start with BA. Then I use this syntaxing. And in the resulting data frame, all item names start with BA. BA, here BA, 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 and so on. In the next example, I want to filter on item names that start either with P or J or K. And as you see, item names start with P or J or K. Let's see the next example. Now I want to filter on item name that start either with K or L or M or N or O or P. In these cases, when the letters are in order, you can use one dash or you can write all letters in bracket. So as you see, item names start with one of these letters. In the next example, I want to filter on item names that contain BA. Whenever I say contains, it means character BA. It's somewhere in a string. It can be in the middle, it can be at the beginning or at the end. So in the first case, BA is here. In the second case, BA is here. In the third case, BA is here. In this case is here. And in this case is here. Let's see the next example. Again, I want to filter on item names that contains ing. It means ing is somewhere in a string. So here ing is at the end of this string. Here ing again is in the middle of the string. Ing is here. In this case is here. Here is at the end of the string. In the next example, again, I want to filter on item names, and I want to filter on item names that contains W or Z anywhere in a string. So in the resulting data frame, here we have Z, here we have W, here we have W, W, here we have W, and so on. So any records that has W or Z anywhere in a string is in resulting data frame. In next example, I want to filter on item names that contains U, V, W, X, or Y. And again, anywhere in a string. Again, since letters are in order, I can use dash. Or I can use all letters in bracket. So let's see the resulting data frame. This one contains U here. This one contains W. This one also W. This one U. This one Y. This one X, and so on. Let's see the next example. In the next example, I want to filter on item names that end with ER. Then I use this syntaxing. So in the resulting data frame, as you see, the item names ends with ER. ER is here, ER, ER, here, here, and so on. And in the next example, I want to filter on item names that end with T. So as you see in the resulting data frame, item names ends with T. Let's see the next example. Here I filter on item names that ends with A, T, F, or C. Then I use this syntax. In the first case, item name ends with T. Second case ends with A, ends with T, ends with C, ends with T, and so on. And next example, filter on columns that ends with either L, M, N, or O. Again, since letters are in order, we write the first letter and last letter and one dash. Or you can write letters one by one inside of the bracket. In the resulting data frame, the first one ends with N, the second one with M, third one with N, fourth one with L, and so on. Let's see the next example. In the next example, I want to focus on suppliers data frame that shows some information related to our suppliers. Now, let's see the first example. In the first example, I want to focus on suppliers code, which is in the string format, and I want to filter on suppliers code that contains 2, 3. I need to again mention that we use .contains function for kernels with a string format. So in this case, since supplier code is in a string format, we write 2, 3 inside of the quotation. And as I explained in previous chapters, when we want to write numbers that are in a string format, we need to write them in a quotation. Let's look at the resulting data frame. As you see, supply code here contains 2, 3, here 2, 3, here 2, 3, and that's all. In the next example, I want to focus again on supplier code, and I want to filter on records that contain 23 or 95. Then I use this syntax. So in the resulting data frame, we have 23 here, 95, 95, 23, and that's all. In the next example, I want to filter on records where supplier code contains 18 or 58 or 38. So in the first row, we have 58. Here also we have 58. Here we have 18. Here we have 38. Here also we have 38, and so on. In the next example, I want to filter on suppliers code that start with 94. The result shows that we have only 2 suppliers code that start with 94. In the next example, I want to filter on suppliers code that start with 75 or 18. So in the resulting data frame, the first record start with 18, here start with 18, and here start with 75. And next example, I want to filter on suppliers code that ends with 29. As you see, we have only 2 records that ends with 29. And lastly, I want to filter on suppliers code that ends with 34 or 73 or 85. We have only 1 record that ends with 34, 1 record that ends with 85, and 1 record that ends with 73. Now let's go to our slides and summarize the last topic, which was wildcards. As I explained in this section, we filter based on elements of a string column. In slide 15, you can see the syntaxing when you want to filter by starting elements. In slide 16, you can see the syntaxing when you want to filter by ending elements. And in slide 17, you can see the syntaxing when you want to filter on elements anywhere in a string, at the beginning, in the middle, or at the end. And at the end, I need to mention one important note, and it's related to filtering. Please note that in chapter 2, I explain you how to do filtering based on the whole content of the string. But in this chapter and in this section, I explain you how to filtering based on elements of the string, not the whole content of the string. For example, if I go to our dataset and consider the retailer number, in chapter 2, I explain you how to filter on retailer numbers which are equal to 00817, for example. But in this section, I explain you how to filter on retailer's number that ends with 17 or start with 00 or contains 12. So this is the end of chapter 3, part 2. At the end, I really appreciate it if you can subscribe my channel and like my videos. So see you in chapter 4.